Hello everyone, this is Waleed and we are here live from Flutter Karachi, and this is our first online event. So uh, we might be facing some problems in the beginning, but we are live now. So let's begin. And I'm Waleed Arshad, and recently I have been titled as the first Flutter GD in Pakistan, and I have been one of the founders of Flutter Karachi. And this is my team. As you can see, we have Rabia with us, we have Taha with us, and we have Rao and Asher with us. These guys will be speaking about different topics here today, and we have one speaker from outside as well, and he will be soon joining with us. So I would like to first introduce you guys to Rabia Wes. She is our marketing chairperson, and she has recently, not recently, but she has been working for us like since last 2 or 3 events. But as a person, she has joined our event for the first time. So we would like to introduce you to her, and I would like to, uh, hand it over to Rabia to discuss about the agenda and the event. So let's welcome Rabia. Rabia, you are live now, so you can speak.
Hi, thank you, Waleed, for the introduction. So first, I want to welcome everyone to our first live global event, and I'll be taking you through the agenda. But before that, I want to give you a brief overview of what Flutter Pakistan is and how you all make a difference to this community. So, Flutter Pakistan is our initiative to provide you all a platform where you can learn about features of Flutter and how you can make beautiful apps to address common problems. So, we as the Flutter Pakistan team are pioneers for this community. However, you all are the ones who will drive it further forward. So, having said that, I want all of you to always share your feedback and suggestions and let us know how you want to learn and what you want to learn so we can give exactly that to you on this platform. Further, I want to encourage that you all participate in our events and also share your experience with us as well as extend your experience to your social circles. So, if there are other Flutter developers who want to be part of the community, they can come forward. Okay, so giving after the overview, I just want to take you through the agenda for today. So in today's agenda, we have three talks, and following those three talks, we have a design task at the end for all of you. So the first talk is going to be by Taha, and he is going to talk about how we can use different architectures to manage states in your Flutter application. Following Taha's talk, we have Kamran, who is going to talk about the uniqueness of Flutter compared to all other mobile development frameworks. And our final talk will be by Rao and Asher, who are going to teach you how you can make Flutter applications beautiful by making them responsive. Once the talks are over, we are going to give you a design task, and we will also be providing you with a link in the comments so you can submit your task over there. And other than the agenda, I want to give two more important tips. So, one is that obviously, when the talks are going on, you will have certain questions. And it would be good if you can put down your questions and we can address them at the end in the question answer session. And the second thing is that we will also be sharing a feedback form with you all. So we would want to know how your experience for our first live global event was and any comments and suggestions that you have for it. So now I'm going to hand over to Taha to begin his talk. Thank you so much for listening, and I hope you enjoy the event.
How are you? I'm Sayyid Tahali, and I'm Sayyid Tahali, and I'm a Flutter enthusiast, just like all of you who are present here. And I love making mobile apps, and I'm currently employed at VentureLife. So let's begin with our session. So today we will be talking about the three most popular architectural patterns that are being followed when developing a Flutter application. So they are namely scope model, block, provider, and we will be having an up close look at them and see how they are how they can be implemented in a Flutter application. So when I say point blank figuratively, it means that they without any explanation. So this is exactly what I'm going to be doing. I will just jump right into how these three patterns can be implemented in your Flutter application rather than beating about the bush and talking about some stuff that I'm seeing elsewhere, that why it's important and how we can manage the state of the large scale applications rather than talking about the actual thing, that is the implementation. How can a developer achieve this thing? So today my focus will be that on how it can be done rather than why and when. All right. So let's begin. Scope model. Let's begin with the scope model. It's one of the three approaches, and what it basically does, it aids you in pass the data model from parent widget down to its descendants, and secondly, then it updates the children when the model gets updated. In my opinion, it's the simplest of the three approaches that we will be talking about today. So let's talk about it, how it's implemented. So all of you must have at least once seen this code if you have ever developed a Flutter app or tried practicing with it. So it's basically their Hello World app or the demo code that's like pre-written when you create a new Flutter project. And what they like the technique they use here for state management, you can say, like when this floating action button gets pressed, and then the value of this variable here counter will get updated or incremented, and then this set state method, this thing will be called, which will update the UI. So the rule here is in this simpler but effective method is that the state is maintained by the parent because a widget can only be rebuilt from their build method. So you can see that in the declarative style of programming, there's a widget hierarchy, a tree of widgets being called, which form up to make up your UI. And if this text is a child of this home page. All right, so this counter variable exists in the home page widget itself, and which is the parent of the this text widget. And so this state is maintained by at least by a parent that is at least one level up in the hierarchy. So this is the general rule here. Okay. So for okay, let's talk about the main classes in the scope model. This what the main classes that the scope model library brings. They are namely these three: model, scope model, and the scope model descendant. Their names are quite self-explanatory, but let me tell you what the model is. Basically a class that actually implements the listenable principles that some consumer can subscribe to it, and then you can wrap this model inside a scope model to pass it down to the descendants who then like subscribe to it. And then the scope model descendant, it will automatically rebuild itself when a change is notified by the model. So wait a second. Okay, so let's see. Let's directly get into a code here, and I'll give you a walkthrough while explaining how these classes and the how a scope model is implemented. So as you have seen this counter application, the demo code, we will see how this thing can be implemented by a scope model. So it will be easier for you to understand. All right. So I have some examples here, and I will be walking you through these. So let me open them and run them. Okay, so this is a scope model example of a counter app. Let me run it. It's launching, so meanwhile it's launching, let me walk you through. boxes were. So it's the same example. We have our class widget here. It's a stateless, and then when we like go down, we see this scope model widget being used that we talked about earlier. What it basically does, it wraps around this model we want to pass down to all the descendants, and makes this model that we have passed to it to all the descendants that are now that will now be in the widget hierarchy in all the widget views. So then we have our app here. It's a simple app. So we have just kept this whole model here. And then if you see the counter model implementation, so it's basically uh, its properties are this counter variable which we will need to update once the floating action button is pressed. And if you notice here in this increment method, there's this notify listeners being called. So this is one of the essential methods that is required here in this case, which will actually notify all the descendants to update their states once we perform some manipulation with the data. Like here we are implementing the variable. So if you go down here, this is our home page, and if you notice, it's stateless now, unlike the map. So because of the architecture that we have just implemented, and if we go down here, then the third widget that we talked about, it's here, the scope model descendant. It actually basically helps you to find the model that you want to use. And there are two main ways to do that. Let's first talk about this, then I'll explain the other one. So here you tell in the generic in what model you want to consume, and that model has been passed down by the scope model here. All right, so we can use its property, like we are using its counter value to show it in the text. And then if you see here in the floating action button, I'm using this another convention. It's the scope model dot of static method that is also used to find the model, and but it has one advantage over this method. This method always rebuild its children whenever the change is notified to it. But in here, we can toggle if we want to, like rebuild the widget when the state is updated, or we just want to use the values from the model or from the state. Like in here, we just want to use this method. We don't want to update or rebuild this floating action button. But in case you want to use this notation here, and it's helpful when we are using multiple when we are consuming multiple scope models inside one widget. I'll demonstrate that too, but first check out this property, rebuild on change. So if we set it to true, just like in this scope model descendant, this thing will also rebuild when a change is notified. But in this case, when we haven't specified it, we are just consuming this value from the model. All right, so the app has run itself, and when you press this button, it's behaved as expected. So I was telling you about when you want to consume, like this was just one model that we have passed down, and we were consuming it. But what if we wanted this text widget to consume value from another model that is not this counter model, that is something else? For our use case, for the sake of simplicity, let's duplicate this model. All right. So if I duplicate it and name it like counter model 2, now I'll initialize it with a different value here. And now I want to consume it. So I want it to be consumed here in this text widget. So let me use string interpolation rather than this syntax. So it can accommodate two values from two different models. We will be using these dollar symbol. All right, so this is the value from the first model, and this is the value from the second model. All right, so I will be using this notation as I explained you, and instead of counter at increment, I will be using this counter value from the counter model 2. All right, but we have to pass this counter model 2 from the scope model. So we will have to add it here. So if you want to add more scope models, like we'll just wrap it in another scope model. and then pass it that same model we want to use. All right, so here we have two different models being passed to this one text widget, and basically if you see it, so this value is from the model 1, and this value is being shown from the model 2. We haven't like implemented its increment method yet in the floating action button, so it won't actually increment when we press this button, but you get the idea, and you also get how this notation can be helpful when utilizing different multiple models in a single project. All right, so this as you have familiarized yourself with the fundamentals, and so let's dive into a more practical example of scope model that will more better explain you how that will better explain you how the scope model is actually useful in real scenarios. So I have this one more example here. Okay, let me open it for you. And it's basically a name changer application. It's also very simple, but it demonstrates the more real power of implementing these kind of architectures in our application. So, all right, let's begin. Let's first launch. Okay, so here you can see that we have our model in a separate folder and separate file. It's up to you to like how you modularize your and how you organize your directory structure. We could have done this the same way for the counter app, but to keep it simple, it was here. So if you like look into this user model, we have a name here, and we have a property exposing it, and then we have a method that will like change whenever this method is called, that will change this value to a newer value, and then notify all the listeners or the descendants of the scope model. So basically what our app will be doing, yeah, it will have two pages, and one page will be showing this thing, and then another page will update this name based on whatever the user inputs in the text field. So let it quickly execute, so I can like give you the demo of the application and then walk you through the code. So here in the main.r file, it's like it's starting just the same as all the apps. So here we are. Here we have our app. We are passing it our user model, and then this user model is like the wrap. This user model is wrapped with the scope model. So this scope model allow all the descendants to use this model, and then we have this our material app. Here. All right, so this is our homepage. It's also stateless here, and it's also stateless here, and we are pushing a new page from it. Okay, the app has run itself. So you can see that the name we have in the model is being shown here. And when you press this button, it will navigate you to a new page where this text field has the same label as that name in the model, and you can update it. Like, let me update it to some other name. Okay, so when I change it, and you can see that the snack bar is using the same updated state from the model. This label is also using the updated state from the model, and when you go back to the page, the same thing has been updated. So it was really convenient for this architecture to do all this rather than the conventional set state way that. All right, so let's look into the code. So here if you can see that we are using this again, this scope model descendant that is like populating the text field with the value from the model, and then on the next page, that is the change name page, we have it's actually stateful just to cater the user input, and the all the values from the model, like when we are all the values from the model are being handled by the scope model, and only the user input by being handled by the set state here. So if you see in the set state, when the user submits, we just remove the text. So in here, as you can see, this descendant has multiple childrens. Like it has this name controller, then it has this raise button, and then it has this snack bar, and all of these are using the model. Like all three of these are using the model. Like one is for using the model value for in the snack bar, the other is for the text field label, and thirdly the all right. So as you can see that using this architecture, all of these architectures, we can like simultaneously share the state between different widgets, and it's very seamless for us. So let's close it and move it to the next one. All right, so where's our next presentation? Okay, so next is the provider. So provider is another approach of like it's basically doing the same thing. It also allows you to create, listen, and dispose a value or an object, and the main objective here is the same, that is creating separation of concern while using dependency injection, like basically moving the business logic out of the view. All right, so but how it's implemented, it's a bit different, but the concepts or the fundamentals are the same, and you will get to know it when we walk through the example. Okay, so and to let you know, this is the officially documented architecture on Flutter website. Like this is the only architecture that is documented on their website, and they like say it's specially made to handle the widgets and the passing of data between them, and it's made by combining most popular approaches. So you will see familiarities with what we already explored and what we are about to see. So the main concepts here in provider are basically there are three things. There are notifier, then there are providers, and then there are consumers. So the names are pretty self-explanatory. Notifier is something that you can subscribe to for and it notifies you of changes, and then provider provides the instance of a notifier to its descendants, and just like what we have already seen. And then finally the consumer, we can access the state using the consumer. All right, so congrats once again. So let's see how the same application can be implemented using the provider approach. All right, so let me first close these windows. All right, and then let me launch this provider example here. So it's basically the same thing. And you can, as I walk you through the code, you can also see the familiarities. But here we are launching. Okay, so here we are like launching our main app here, and then you can notice that change notified provider is being used, and there are several types of providers, but what you need to focus on is basically that there are providers, and each provider has some different functionality, but the essence is the same. So here is this the change notified provider, which actually notifies the change. Then there is this simple provider which doesn't notify the thing, and you can just consume the value. And then there is proxy provider and several others. So to keep it simple, let's call it provider. We have this provider here, and it's basically allowing this counter model to be consumed by all, any descendant that wants to consume it in our my app. All right, so the counter model is the same here. It has this value variable and then this increment method, which also notifies the listener, just like in the scope model. So here our app once again is stateless, and it basically implements the simple middleware app widget, and here we have our homepage. So in our homepage, what's different actually? Like here instead of what we were using in scope model, you remember we were using this scope model widget, but here instead we are using this change provider. So they are basically doing the same thing. So okay, and then secondly, to how consume it, we have this consumer widget here, which which has a generic, just like you specify in the generic which model you want to consume or which notifier you want to consume. So the syntax goes like this. It has a builder method which builds the UI for the app. And actually, let me explain also. Maybe some of you have questioned what are these parameters in the build method. So basically, this is the model, and this is the context we marks, and this is the child widget. That this is the constant child widget, which I haven't passed it yet. But if you like pass it some constant child widget, it will not be rebuilt when the state gets updated. So if you have, like, if you want to use some widget inside here that you don't want to rebuild when the state gets updated, so you pass it this constant child. All right, so everything else is the same fundamentally. Like we have consumer instead of what? Instead of scope model descendants. All right, and then we have this notifier, and then lastly we have this provider. All right. So just like before, we also have this notation here with this, which is provider of, which lets you directly call the value from the model, and we can set the listenable to false here, just like in the scope model we were setting the boolean to, just like. All right, so let me run the application. It's basically the same, just as you have seen, we have implemented the same functionality using the provider widgets, like the widgets that are provided in the Flutter provider package. And you like register these dependencies here. You register this Flutter dependency here, just like you registered the scope model here. And lastly, you will be registering a block dependency here. So far, we have seen examples of two architectures that are namely scope model and provider. Okay, there's one significant difference between them, which like actually like when I was like had to make this decision which one to use for my app, I went for the provider just for this one major difference. Otherwise, I found the scope model very easy to be implemented, because it keeps the number of classes or number of widgets limited, so it's easier to understand. All right, so the key difference, what I found was this: in scope model, when a single widget wanted to consume multiple models, what we had to do, we had to like nest our widget in multiple scope model widgets, just like these. Like this is one model we want to pass down to the descendants, and this is another model that we want to pass down to the descendants. All right, so but the major difference in the syntax of the provider here is it lets you define multi providers. Like it lets you give an array or define an array where you can define different providers, which can then be consumed by the several descendants there are. And as you can see, there are different types of providers, so you can read about them on your own. All right, so this was the like major difference that like this reduces also the lines of code and also increases readability. And I think this is the better approach to take rather than this. But all right, so let's move on. So we have seen these two approaches, and now lastly we will be talking about Bloc. Okay, what's so special about Bloc is actually it recently in this month, it has become more popular. The repository on GitHub has gained more popularity than the Flutter itself. Like, can you believe it? This architecture is being implemented by so many because it has all the goodness of the reactive programming or the reactive mobile app framework that are now very popular in React Native, and we have this RX in Android. So this sums up all the goodness of these architecture. It's not like that we don't have Redux in Flutter, but what's gaining more popularity, like this is the better package that like lets you implement reactive mobile frameworks and lets you manage the architecture well. All right, so Bloc attempts to make the state changes predictable, build complex app by composing them of smaller components. So let's see what the core components concepts are here. So they are namely and now as you can see that things are getting complex, so don't get afraid. Okay, when I will explain, you will find it very similar to what you have already seen and essentially easier to implement. Okay, so we have these core concepts here. There are events. Basically, events are inputs to a block, you can say, and then we have states. States are the output of a block, and then we have transitions. Transitions are they change from one state. They change from one state to another is called a transition, and a transition consists of the current state, the event, and the next state. So basically, when you are like making the transaction, you have these properties available, and if you want to do something in between that, so you can do that. And then we have streams. So like in the reactive programming fundamentals, you must have the know-how of streams, and let me explain you very briefly. You can assume it to be a water pipe, and it has water flowing through it, and you are like you have tabs at the end of it to like you are subscribed to that water stream. So basically in computer science terminology, it's a sequence of asynchronous data that you can subscribe to and like get updated when the data gets updated. And lastly, blocks. So what are blocks? Blocks are business logic components. It's their full forms, and it's a component which converts a stream of incoming events to stream of incoming events to a stream of outgoing states. So basically, events, as you know, like we just discussed, that they may be triggered by press of a button or life cycle events, and states will get updated, as we have seen that incremented counter variable. And so these were the main core concepts, and these are the main classes that this library brings along with it, and they are namely block provider, block builder, and the block. And you may notice now, you may now starting to notice the similarities here. All right, okay, so okay, stop sharing for the counter app. Okay, this is the last time. Okay, seriously, last time. So here's another example of a counter app being implemented via Bloc. So let me open it. All right, and let me run it. While it's running, let me walk you through the code. And I'm assuming that you are easily able to see this code. All right. Okay, so let's talk about this block dedicate first. It's a handy concept, but okay, my throat is getting really dry, and this is the first Ramadan, so like we are not really used to it. So all right, bear with me. So simple block dedicate, we have This is basically not doing anything here, but just to like let you know about the syntax and the functionality. That it's exposed. Let me walk you through it. We have this block delegate class here, which we can extend in our Dart class here. So what this block delegate class brings along, it basically lets you override the on transition, on event, and on error methods. And what it basically lets you achieve is that for every transition that takes place in your application that has the block architecture implemented, you can write some functionality here that will be executed each time a transition is being made, or each time an event gets triggered. You can write some functionality here. It's basically doing nothing here. It's just printing the details of the event or the transition here, and then calling the super, which is basically do whatever you were doing. But you can implement this simple block delegate like this, which is a very handy thing when you have it in your application. You will come across scenarios when you will be using it. So when you define this simple block delegate, we have this block supervisor here, and you can pass it this delegate to him, so your app will know like what to do when these events and these transition or these errors occur. So now back to our application here. Let's first it's launched. Let's first demo it. So okay, it's a bit more it has a bit more functionality than the other counter apps we have seen, and that's good. It's refreshing for me to see at least 3 more buttons. So here they have basically implemented this one more event for the decrement instead of the increment. So you can also decrement the counter value here. And then we have this button which can toggle between the dark and light themes. I'll like walk you through the code and how it's it is implemented in the block architecture. And lastly, this button will throw a exception, and this and you will get to see like how we are handling exception via block architecture. So here it throws this exception. So let's work line by line. Okay, we are done with this block delegate, and now as we talked about these classes here, the block provider, the block, and the block builder. So here we have this block provider, which basically just like what we have seen, it passed down a block for builder or to be consumed, and then this block can be consumed in the descendants or the children. All right, so then we have this block builder, and if you if I decrypt this syntax for you, it basically says that this is the block and this is the state of the block that we will be using inside this builder method to build a widget. Like it will be using the block or the business logic inside it and the current state of the block and using that and to build the widget. So what actually this block is made up of, let's first dive into that. So this theme block here. Okay, so you may notice that we have this enum, which basically has just this one value toggle, and then we have this theme block here, which is implementing the logic to toggle between the light and dark themes. So there are 2 methods that are being overridden. One is this initial state, and another one is this map event to state, like we talk about. And if you decrypt this syntax, it basically say what that a block converts this input event into this output state or output data, or you can say like it converts this input theme event, which is basically a toggle, and gives out the theme data. All right, so initially we set this theme data to light theme, and then based on whatever when the toggle event is received, we call this method, and it lets you toggle between the dark and light themes based on this simple ternary operator check. If it's dark, change it to light. If it's light, change it to dark, and then yield the state, which means basically notify all the block builders that we saw above. All right. So this was our theme block, which had this business logic, and then this block was being consumed by this block provider here. Okay, and then we further go down here, so it's calling this home page, and then we have another block provider here which is providing this counter block to the rest of the descendants. And we have this now we have this counter page here. On this counter page, as we have seen, we have four functionalities. So we will be like seeing how the events will be triggered for these functionalities and how the block builder will be consuming those events. So first, this block builder that's consuming the counter block, and this is the current state of it, like what value it has. So first, let's dive into the counter block implementation, it's implementing. So the counter block here is implementing these two methods, which are basically based like let's update the state based on these counter events that we have defined. So it takes in this event and then churns out this in state based on this event. So initially the state is 0, it's an integer, it's 0, and here when we map the event to state, if the event was a decrement, then we decrement with -1, and if the and then if we have this +1, right? So then if we have this increment, then we +1, and lastly, if you see by default, it throws an exception. So if any other event is received, it throws an exception. So let's see how any other event is received, how decrement event is received, or how increment event is received. We just saw how the counter block implements the functionality. Now we'll see how it's being consumed. So all right, so we have our floating action buttons here, and we have 4 of them. The first one consumes the counter block like this, like it's called the counter block. I want to call this block, and then triggers an event for this by calling this add method, and it lets know the block which event it wants to trigger. So we are triggering this increment event, and then the rest is handled by the block. If the increment event is triggered, you know what happens. It increments the thing, and then the block provider, the block builder that we have seen above, uses that value which got incremented and then displays on the UI. And same is for the decrement event here. The second floating action button actually invokes the decrement event, and lastly, skip this one. And lastly, when we return null, the counter block throws the exception which we just saw. And for this theme thing, we just trigger this toggle event, so which means that it will toggle between the light and dark themes. So this basically explains all the fundamentals of the 3 most popular approaches that are being used in the Flutter application development nowadays. And let me know if you want more clarity on any of these concepts by the end of the session when we begin our Q&A, and save your questions for that and post them in the comments when we begin the Q&A. If you comment them, they may get lost, so save them for the end. And I hope you must have learned a thing or two from this. All right, let me show you a few things before I sign off. Okay, so here are the credits for the examples I just showed you. I haven't ordered these examples, so I have posted the links for the rightful owners who are maintaining these repositories, and they are these slides will be shared with you when I'm done with the presentation. I think on the description or in the comments of the YouTube, and you can go on these links and see for yourself. Lastly, you can connect with Flutter Karachi by following these links. We are on Facebook, we are on Slack and Twitter, and you are on YouTube at the moment. In Slack, this is a more focused group where we tackle Flutter related issues for the community. Like community members help out each other, and there are several channels like job posting, journal announcements, and dev problems. And then this Facebook page that keeps you updated to our latest happenings. And thank you so much. All right. Okay, nextly, Kamran will be coming up to give his talk.
Hello, Kamran. This is share your screen and you're live now. Thank you.
Okay, so Assalamu alaikum. My name is Kamran, and I'm a software engineer at Central Depository Company of Pakistan. I have been working on Flutter since 1 year. So today, my topic is how is Flutter different from other platforms. So before I start, I want to give you a short introduction of Flutter. So let's move on to our first slide. Okay. So basically, Flutter is created by Google, and with the help of Flutter, you can develop beautiful natively compiled applications for mobile, web, and desktop from a single code base. Yeah, you hear me right. From a single code base, you can develop applications that runs on all platforms. So if you don't believe me, then I would like to tell you that the presentation that you are seeing right now is not created in Microsoft PowerPoint or Google Slides, but it is totally designed on Flutter. So basically, it's a Flutter application that I'm using for my presentation. So it's a Flutter desktop application right now. So if I run the exact same code on my browser, so I will get the web version of my presentation. Well, as you see in this, well, yeah, this is the web version of my presentation. So in my Chrome browser, in which the same code is running, and I got the exact same result. So this is my desktop application, and this is my web application. So this is the power of Flutter, that with a single code base, you can run the application on all platforms. So I will share you the code of my application at the end of my presentation. Okay, so Flutter apps are built using Dart. Dart is a simple object-oriented programming language, and it is also created by Google. Platform differences means, suppose I have two screens in my application. The one screen is developed on Flutter, while the other one is created on the native side. That is by using Java or Kotlin for Android, and Objective C and Swift for iOS. So that native screen can be called by Flutter by using the platform channels. So it is a big advantage of Flutter that your native code can easily be called by Flutter with the help of the platform channels. So the fast development, well, so there's a feature in Flutter called hot reload that helps developer to develop applications really fast. So if you are going to change anything on your screen, so you will not have to rebuild your application again and again. You just press the hot reload button or control plus S on the Windows machine, so you will able to see your change in less than a second. So that's a big feature that Flutter provides us, the hot reload. And the Flutter also ships with a rich collection of pre-built widgets that make your development even more faster. It's a flexible UI. So the Flutter framework makes it easy for you to build user interfaces that react smoothly in your app. So your users will love your app natural look and feel because the Flutter implements platform-specific scrolling and navigational patterns, fonts, and many more. So if you see the scrolling behavior that you see, the scrolling behavior is same in Flutter as like in the native. So in Android we have some the top bar, and in iOS we have some the bouncy feel. So this is the same in Flutter. Okay, so everything is a widget. Well, in Flutter, everything is a widget. Your text, your button, your image, these all are widgets. Basically, your whole application is a widget. So widgets are the basic building blocks of a Flutter app user interface, and widgets are arranged in a hierarchical order to be displayed onto the screen. So if you see there's an simple screen in which we have a logo and we have the two buttons. So this is the hierarchical tree of that screen. That first we have the material lab, then we have a scaffold, then we have a column. And column has two children. The first one is logo and the other one is row. And the row has also the two children, that is the button 1 and button 2. So basically in Flutter the widgets are arranged in a hierarchical order. Okay, so why Dart? Why Flutter uses Dart? Because Dart, as I told you before, that Dart is object-oriented programming language, and Dart also supports the AOT ahead of time compilation and JIT just in time compilation. Ahead of time compilation is used when your application is ready for the release, for the production. Then your application is compiled by the AOT compiler, and when you are developing your application, when your application is on development stage, then your application is compiled by the GIT compiler. Because of this, the GIT compiler, you use the hot reload functionality and avoid the separate layout language. That means that in Flutter you don't have to rely on any other language to draw the layout or the screens. That you don't have to draw your widgets in something like the XML or HTML. So you just create your layout totally in Dart. So you designs your screen in Dart programming language. And the final one is easy to learn. But Dart is very easy to learn. Okay, so Flutter versus other frameworks. So we have other platforms as well that provide the development of cross-platform application. We have the WebView platforms, frameworks, and the other frameworks, something like Xamarin and React Native. In WebView, we have Cordova, Ionic, ToolGap, something like that. Okay, so WebView. So in WebView framework, you are not actually created a mobile application. You are creating a website by using HTML, CSS, and JavaScript, and you run that website inside the web view of your native platform. So you see that the web view. So you just one that website inside the web view of your native platform. So when the end user looks at his mobile, he will think that he is looking at a mobile application. So basically, you tricking your end user that it's a mobile application, while in reality it's a web app. So basically, you are writing a web app and then using it as a mobile app. That's why it's we also call it this framework as a hybrid app framework, because you actually this is a website, and this website is actually running in the web view of your native platform, of your native system. And also, so as you see in the image, to access the services of your device, like if you want to access the location of your device, or camera of your device, or audio or bluetooth, something like that, so you need a bridge to communicate to the native system. So you need that bridge to access, to communicate to the services of your native application. So, because of this process, your app will be too slow, depending on the feature that you need. So, this adds another drawback to this system. So, because of the bridge, you have to access these services. You depend on that bridge to access the services like the location, audio, camera, and etc. Okay, so React Native, that how React Native interacts with native components. So as you see in the image, the React Native expands the bridge concept. React Native expands the bridge concept in the WebView system, and now the bridge is not only uses for services but also to build widget as well. So the advantage that sorry, so the disadvantage of that is, suppose you have an animation in your app, and in that animation, one of your widget has to build hundred of times. So due to this bridge, you may face the performance issue, as well as the smoothness may not be so much efficient. And the React Native is heavily rely on the OEM widgets. So that's why you got the native look from the React Native platform. OEM means that, as you know, that there is a design difference between the Android and the iOS. So let's take an example of the button. So as you see, the button design is look different on the Android device, and the same button is look different in the iOS device. So when you run your React Native application, so it automatically or identify the platform and draw the design of that button as per the platform. So it automatically identify that which platform your application is running, either it is Android or iOS, and it draws the same design as the default button that is used in the Android or in iOS. Okay, so how Flutter interacts with native components. So as you see in this image, that before in the React Native and the web view, that they are using the bridge concept to communicate with the services. Well, the web view frameworks used bridge to access to the services of your platform device, some like location, camera, and something like that. And the application is running on the web view of our platform. While in the React Native, the bridge concept is expand, and so you have to rely on that bridge to communicate with the native platform. But in Flutter, the Flutter removes the bridge concept, and it also does not rely at, on the OEM components, because Flutter renders your app itself rather than letting the platform do so. So the application is rendered is the rendering work is do the Flutter, not the OEM, not the platform native device. So the Flutter renders your app itself and then letting the platform to do so. This means your app is super fast and responsive and can run on whatever platform you would like, because Flutter actually draws that widget on the platform. It doesn't use the any OEM component, something like that. The widgets rendering, if you see, the widgets rendering is in your application, and it just draw that widget on whatever platform your app is running. So before at start, I show you that my presentation, the application, that it looks same in the desktop application and in the WebView application. So there is no difference at all between these two designs. So that's why, because the Flutter actually draws that widget on the platform. So and there is, as you see, that there is no bridge to communicate these platform services. But instead of bridge, Flutter uses the platform channels to communicate with that services. As I told you before, that if you have the two screens, that one is built in the totally in native, then you can call that native screen from your Flutter applications through platform channels. So to use the services of your platform, it uses platform channels, and it's difficult to use. So it's not difficult because of the platform channels. It is not difficult to use the platform APIs, which means that if you need to use a specific Android or iOS feature, so you can do it easily. You can easily access to that the specific platform native API. So, and because of that, the Flutter also makes it possible to create plugins using channels. So that can be used by every developer. So you just some put simply you just simply a code, and that code can be run by anyone else, and that code is run on every platforms, and you use it, yeah, and you use that code on everywhere in whatever you want to type to run that code. Okay, so the key points of the Flutter are that with Flutter you have a full control over the entire rendering stack, and you create a reactive views with no bridge and great development experience with hot reload and fast, smooth, and predictable UI that you can make on the Flutter. And you can also deploy to your Flutter application to multiple platforms from a single code base. Okay, so let's talk about the difference between these the frameworks. As I told you before, that Flutter needs no bridge. No bridge is needed in Flutter to interact with the native side, while in React Native and other frameworks like the web frameworks, you need a bridge to communicate to the native side. So because of that no bridge, there is a great performance you get from the Flutter. While if you're comparing the performance of Flutter with the React Native and the other frameworks of the web frameworks, then you got a great performance in Flutter. Okay, so which collection of pre-built widgets? Yeah, the Flutter also comes with a rich collection of pre-made material or Cupertino widgets. So that can be customized easily. So you do not need to make widgets from scratch. You just write that. You just take that widget on your code and you just customize it as you like. So basically, the Flutter comes with a rich collection of pre-built widgets while comparing to React Native. No optimization required. Yeah, because of that pre-built widgets, and because the Flutter does not rely on the OEM native platforms. So that's why there's a no optimization required of your widget, because you render your widget in your Flutter application, and you just drop that widget to the platform device or something like that. So that's why you don't need an optimization for the Flutter. But in React Native, because the React Native is rely on the OEM components, so that's why you maybe requires a separate optimization for each platform. Because as I told you before, that when you run the application, when you run the React Native application, then it automatically identifies the platform, that on which platform you are running your application, either it is Android or it is iOS. So it's automatically identify that platforms and draw that component or widget on the screen. So that's why you maybe requires a separate optimization for each platform. So documentation, yeah, Flutter is a well-organized documentation. If you go to their official website, the flutter.dev, so you can see that there's a very well-organized and proper documentation of Flutter as compared to other frameworks. So yeah, in 2019 last year, Stack Overflow just revealed the result of the most loved framework of 2019, and as you see, that Flutter is on the third place. So Flutter is gaining a much popularity in the last couple of months, and as you see in the result of the Stack Overflow. Well, now I would like to show you a login screen that can be easily developed in Flutter as compared to other frameworks. I just open that screen. So just this is the indicator. Well, the application, yeah. So this is a simple login application that is created in Flutter, and from this screen, what I am trying to show you, that as you see, if you write an email, so if you see the face of the panda, the teddy is on to the text field, that what you are typing in. So let's say that we are typing something like this. So the face is removed according to the text changes. So, and if I write the password, so you see that it just hides your face, because there's a password. It's not a public one, so that's why I just show the respect to that password and just hide the face. And if I try a different password, like if you see that the hint is given that try bears, but if I try something else and I just click the sign in button, so that's a sad reaction that the partner gives me, that your password is incorrect. So as you see that the partner gives me a sad reaction that you type an incorrect password. But if I give him the password that what he wants, then if I click the sign in button, now the tidy is happy. So that is the animation. That is the thing that I want to show you, that this can be easily achievable, uh, easily created in Flutter, but as compared to other platforms. And it is not an image. It is not a GIF image or something like that. If you, because you can't get that smoothness, that type of smoothness from the image. So basically what is used here is the I just yeah. So basically what this character is made in the Rive. Rive is the website is created by the 2D Dimensions. The previously named as a Flare, now they changed their name to Rive. So this is the character, this is the panda that I'm using in my Flutter application. And as you see that in the bottom left corner, we have the animations. So we have a fade animation, test, success, and idle. Idle. So if we click a fade animation, that the same result that I got when I entered the wrong password. And if I run the test, so it's just moving its face. I show you that when I write an email address, or then the face of the pan of that teddy is moving according to my text. And we have a success animation in which that I just show you that when I write the correct password, the bear password, then the panda is happy. So that animation. And we have idle, a simple panda application animation that you are just seeing right now, that one. So how can I achieve this in my Flutter application? That I just give you a quick overview of that. Just if you see the code that if you are a new developer or a beginner, and you saw that screen, that the first thing comes in your mind that, oh, that is impossible. That how can I draw that type of screen? But in Flutter, this is really easy. So I just want to show you a code of that application that you just you just integrate that Flare file into your Flutter application, and then we have this animation, these nodes, the fail, the test, success, idle, and we play around these animations with the if-else case. Like if the password is correct, then play the fail animation, and sorry, if the password is wrong, then play the fail animation, and if the password is correct, then just play the success animation. So that's simple. So I just want to show you the code of that. So if you see here that if you take the variable of the is covering eyes as a boolean, we initialize to the false, and if if the focus of our text field is on the password, then the covering eyes variable values change to true. And so if the value is true, then well, it's a little bit of old file, so that's why it's not available. I will share you the updated file of that Flare file of that teddy. So that's why the animation of the hands up and hands down are not available here. So if the cover is true, if you are focused on the text field, then the value of that is covering eyes will be changed to true. And if it's true, then just call the method play that is comes with the Flutter Flare package. So just play the animation of hands up. So it just play the hands up animation. So you see that when I click on that, when I focus on that password, so it just hides your face because that's a password. Because in here I play the animation, the hands up. Else, when the focus is lost, then just hands down, then remove the hands from the face. And the same goes in the submit password method. If you see that method, that if the password is equal to bears, then play success. That as I just show you in that's the success node. So just play that success animation if the password is true. Otherwise, play the fail animation. Simple. So it's just if else case that you are playing around with. So it's not difficult in Flutter. Well, if I told you to create that type of animation in any other platform, so I don't think so. In my opinion, I don't think so that it is possible in that easy way. You just import the file is there. This file is you see in the assets folder carry.flr. You just import that file in your Flutter application, and then you just play around with its nodes, as you see here. So, and one more thing, how can you create the character in that website? Well, basically, it's much more like the Adobe Photoshop or Adobe Illustrator. So if you are a designer, if you are working on the Photoshop, then I don't think so that it will be difficult to learn the Vive. So if you see the website of the Vive, we have the other designers have also built the characters there you see that character that is also developed by the designers. So you can just import that file in your Flutter application and just play around it. So that's I think the that gives you the full flexibility that you can create any type of UI in Flutter with the help of Riot. Any type of animation you can develop in Flutter with the help of that UI. Well, if you see the smoothness of this design is very smooth, is very efficient. That is not hanging something like that. Okay, so yeah, so I think that's it from my side. So that is the GitHub link of the presentation, the code of my presentation. So yeah, and I want to tell you one more thing that right now this my presentation have some bugs about the responsiveness. So I show you that my application runs great in the web and great in the desktop, but in mobile it may be crash because right now this is the not as the responsive is not as much responsive. So after my talk, there's a talk by the Ashar and Numan who gives you a brief detail about that how can you create a responsive design. So I just want to give you a task. I just want to give you guys a task that please listen to that talk, then apply that knowledge, then go to my GitHub that project, clone that project, then try to apply that knowledge in my project and try to make that presentation more responsive that should be running on the mobile as well. So, and that is the Medium link that I just show you the Teddy login screen demo. So you can get a complete article and the source code from that link. So I think that's all from my side. So now I would like to invite the Ashar and Numan to tell us about how can we develop a responsive designs in Flutter.
Thank you, Kamran. You are great. You win the race for Flutter. Assalamu alaikum. Hope you are all fine and quarantined. Once again, thank you for attending the event. Our topic is building responsive layouts using Flutter. This talk is represented by me as Asharzia and Raunaman. So, who we are. Currently, I am working on TPS Worldwide. Share. I think we are sharing a screen. So, first, currently working on TPS Worldwide as a software engineer, developing mobile apps. Yes, developing mobile apps on Flutter for fintech domain. Working as a mobile developer is not easy because there are several challenges occur due to platform dependencies, lack of rich features, and so on. So Flutter changed my development experience. So this statement is the result of more than 3 years of experience. Now I am requesting Raunaman for the introduction.
Hello, Assalamu alaikum. My name is Mohammed Oman, and I'm a software engineer ex Expert Digitals. I have a core experience of mobile development from 2 years, 2+ years, and my core experience on Flutter and other mobile cross platforms like Sony and React Native and iOS Native as well. So, for further explanation of the responsive UI, should please.
So, Acha. First, we see that what is the problem which makes our UI non-responsive. So the main issue is here the hard-coded values for dimension and positions of your UI widgets. To solve the problem, just don't to solve the problem, just don't use the hard-coded values, so it can become responsive. But that just to solve one part of problem, because in responsive UI you don't just scale widgets. Sometimes you reposition them, and other times you change them according to the available space. In this scenario, we categorize our responsive design into three categories. First is the screen size, second is orientation, and last one is device type. First, whenever any one of them is changes, the app UI changes. For example, if you have a list of images in one column in portrait mode, it should become two columns in landscape mode to show as much as possible to the user in one page. In this little example, the UI depends on the orientation of the device. Now we see that how Flutter helps us for building responsive UIs. As Flutter support both Android and iOS devices, and both of them come in a wide variety of sizes. It's impossible to make a layout for each one of them, but it's possible and very easy to make your one layout. Scale to fit all of them. And in Flutter, we have a set of widgets that help in this situation. So my partner Rao Numan is here that gives information about those widgets.
Uh, so now we are using some build widgets that will very useful to gain the responsiveness in our code. So the first that we use in our code is layout builder. Basically, in layout builder we can create the view, and you can design the child based on the parent side. For example, if you want to your parent will be render on different screen sizes, and you need your child to be take the size as as your parent size increases, or maybe it will render on the small screen sizes. So for that we use the layout builder. Basically, the layout builder uh, always matches the parent's widget side, which takes two parameters like build context and the box constraint. If I further explain the build context, basically it returns the location in the widget trees and return the context of the widget, or the other one is the box constraint that gives the parent widget's width and height, which can be used to manage child as per the parent sizes. Uh, for next, a media query. Basically, when it goes to the different mobile sizes, we need to take the size of each device, and in portrait and landscape as well. So for that size, we need the height and width of each device. So for in Flutter provides an easy widget of media query, which is an inherited widget that informs the current media at the size and orientation, either a pixel ratio. For example, if I go to the real scenario of the applications, I have to create a drawer, and I want to show it like if it's render on the portrait or landscape or other than a mobile and a tab. So we need there a device size to manage the UI. So for that we use the media query, and it will take the context of the media and give and provided size, aspect ratios, and others. So the next widget we are using the orientation builder, a simple widget. Basically, the orientation builder is a widget that's layout the orientation. For example, in a use case of real life scenarios, like today's we are need to design the mobile application for portrait and landscape as well. So for make our UI respective and responsive on the behalf of landscape and portrait, we use the orientation builder check to either the device currently rendered on the portrait or landscape. So at that choice, we will use the build verticals layout and build horizontals layout, like that if I want to render the portrait mode or a landscape. So let's this is the some short description of the widgets. Now the screen shows you a UI which we are going to create. We will show you the how this UI created as a responsive by using these widget and some other widgets. So let's dive into the code. uh, First of all, this is our project, and I'm providing you some pre-reg detail about this project. Is that uh, uh, we are using that main.dot file for rendering our home screen and detail.dot for other screen, right? And for the data that we use in the application was a simple JSON response, which I parsed and used in the data.json file, and some assets which I will required to render. So let's dive into the code further. Basically, for the achieve this UI, we are using a plugin device preview to show you basically the preview render or different screen size. Like on when I run it on an emulator, if I don't use this plugin, so I will show you only the app. The single app response, right? So I use the device preview plugin for just to render it on the different devices like iPhone, iPad, Android, and so, let's dive into the Flutter boilerplate. Start from the Flutter boilerplate code that provided. So basically, this is my main application that runs when the UI when the application launches. So it takes a material app in Flutter. The material app provide the basic things, themes, title of your applications, and it takes a widget which I created with the name of my homepage, like my dashboard. Perfect. So defining these properties, I use the plant data to take the data from my JSON response, and it will render out from the init state to read from the file. So when I share the GitHub repo, you can easily get and check this for the rendering. So uh, let's dive into the basically from the my home widget. I'm using the safe area device to take in all the rendering side from the margins, and in child I rendered a scaffold widget. So what is scaffold? The scaffold basically clearly provide widgets by the Flutter to achieve material design easily. Like in basic UI, I need to create an app bar and a body, or maybe there's a need of bottom app bar, or any need of bottom app bar sheet. So we use scaffold. Basically, this is the main part of the widgets class in the Flutter widgets. So once I run it, so basically, what are shown on the UI is a body in which I take a widget center and a text or a Flutter. So when it's come to the UI that I shown you, in the slides, basically what I need to check what the hierarchy I need of the widgets to achieve this. Like for example, if I take the home screen, so I need a column in which I will take my column to arrange my children's in vertically. And for the vertically widget, first I need a search bar and then a list view that is scroll horizontally, and then I want to take a grid. So let I comment it out this code and run my code. So here, as you seen on the screen, I take an is loading tool. When is loading tool, basically this tool is representing either my data is loading from the JSON or not. Or then in go to the loader, show the loader. It's a simple progress bar container that show the loader, and then I go to the main container. So what's main container contain? Basically, main container takes the media query that I explained previous, that its orientation is portrait or either. on a large scale. So in container, what we are taking in container child, we are taking a column. Basically, why we use column? Basically, in Flutter, a column is used to render a child vertically. So I use the cross-axis alignment as an stretch to expand in the screen width. And in its children, I take three childs. Like I given it the padding from around, and the child text Flutter with you, the one and the second, and so on. So now dive into the first child, which was search field that we want to create. So basically, what I written in the as the as in the first child, I defined a build search widget, which I define which I created custom, and now let's go to the its definition. So I will explain further the code. So in the build search text form field, there I take a text form field widget which takes a search controller. Basically, controller is used to take the whole control of the text field, either it's text or make it read its text or any validation applied to it. And I create a box decoration that will take an icon button of the search on the right side, and its accent color. And I have the search here as a in text, and for that I use the enable border, and for making the border circular round, I take I give in its border here. So basically this is a text form field, a basic text form widget, and the properties which I define in this widget are it is the Flutter text form field basics. So goes to the next widget. I need a build header list where I will describe my list horizontally. So now I'm going to render out my build header list. So for the build header list, when it goes to the build header list container, basically what it's taking out, it's a list view builder, a Flutter list view builder, and I take its scroll direction as in horizontally, basically to horizontal like scroll like horizontally, and I take the data count, plant data, which I load from the JSON. I take its item count to as the length, and for the item builder, I just provided a flat button text. You also need you also take here text with a depth guesser. It's all upon your choice. So we use a flat button for it. So now we need to go for the next widget type, which is grid view. So for the grid view explanation, I will give rotation to Asher to describe it further about grid view.
So here is a grid view in which each card has a different size according to its image size. So here we use staggered grid view plugin. This shows that Flutter has rich plugin support as well as is local widgets. So for the example, we use staggered grid view and staggered grid view widget in which it decides the content of the card on which card is shown according to its size. So here we have a card in which we have a column of image and its detail. If a image size is not up to the mark, it hides its detail, but it contains some details with its child. So here we have a build card image. We split into the widget methods to clean the code. In build card image, we have an image in which it is an asset image, in which it is an asset image in which our plant image is presented. Then we have a description. In description, and the notable widget is a large screen check. The large screen check is the large screen check um, um, checks the orientation of the image or device, and then and then it checks the width of the UI, that it is greater than 600 or not. If it is greater than 600, then it is considered to be large screen. First, in the starting of the presentation, we have I am told you that our responsive design consists of three main categories. That is orientation, that is screen size, and last one is device type. So here is we are checking the device orientation of the device, and then we check its screen size. First, we first we check the screen size of the of the orientation. Then it is to be considered as large screen or not. If it is considered to be as large screen, then we have uh, we have decided which children are to be placed according to the size. So we have in the starting of the main container, we have a large screen check, and then we have check across all the widgets that enlist in the UI. So here we have a home screen in which search bar is here, header list is here, and our cards is here. When we come to the detail screen, we have another orientation. We have another layout in which the screen is on the top, and then description is in the on the bottom. So first, we see that how it is possible to make responsive uh, uh, according to the UI size. So we have our header list in which list view is present, and I have a large screen check in which if a large screen is here, then we select the font of the according to the size, and if a smaller widget is here, then according to the layout. According to the layout, text theme is set. So we have covered two things, that is orientation and large screen. In the detail screen, we use different type of widget, that is orientation builder. Orientation builder gives the builder widget gives the builder function in which the context and orientation has passed, the current orientation has passed. We have different approach on this screen. So first we select the orientation mode of the orientation. If the orientation is in portrait mode or in landscape mode, then uh, uh, we will decide the layout according to the screen size. So first is image. We use align widget in which alignment is decided on the mode of the orientation. If the mode of the orientation is portrait, we align the top center of the uh, of the screen. If landscape mode is present, it is on the top left. Let me show you. See, the image is on the top left of the screen when I rotate the device. Similarly, its width and height is also decided according to the orientation. So our presentation is about the responsiveness of the UI in Flutter. So here we achieve these layouts using these widgets. So we have different platforms on different sizes. I have a simulator in which Apple devices are here, Android devices are here, and we see that iPhone 5, and in which layout set accordingly, and I have rotated it. It also set its orientation and its size according to the orientation and its size. When we come to the large devices, we the app UI changes. The app UI changes, and it sets the layout accordingly. When we come to the iPad Pro, the font sizes and its orientation and its layout sets accordingly. When I rotated it, it's become responsive. When come to the Android on a small device, it works perfectly. When come to the medium tablet, the font sizes and its layout and its sizes set accordingly. So our presentation is here. Our presentation is end, and we will come to this slide. So thank you for joining us. If you get the code of our repository, then link is here in which you can get the code. Uh, Over to you, Waleed.
Thank you, Ashar. That was nice. So let me add the others back and we can have an ending note. So guys, thank you so much for joining us. I'm sharing some links in the comments so you guys can uh, let me just share some links in the comment and you guys can go through those links. So I'll be sharing two links. The first one is the feedback form. The feedback form has feedback for individual speakers as well and individual sessions as well. So this is the feedback form. Here you go, in the comments is the feedback form, and we have one more thing for you guys. So you just saw the last talk about the responsive design, which some of the points were given by Kamran Ali as well. So we have this design talk, the responsive UI design. So we have this task for this for you guys, for those who are watching, and for those who will watch this video afterwards. So the way the rules, all the logics that Rao and Ashar gave in their talks, you need to apply those, and you need to build a responsive design of your own. That is your task, and it's up to you totally. So I'm just sharing a link in which you will submit your responsive design task, and we'll just feature some of them which we like and which stand out among the others. So what you have to do is you have to just go through the link I'm sharing. The link says that you have to share a GitHub repo, the design task. This is the link. You need to share your GitHub repo. The GitHub repo should be public, and it should have a README file with it, and that README should the README should have a complete animation of the responsive design that you are creating, and it should have the rotations and all that, all the video. So you can like record your screen, and then you can convert it into a GIF, and then you can add it into the README of your GitHub repo. So you need to do that so that we can see and we can check what you guys have created. And your GitHub repo should be buildable on the latest Flutter stable channel. All of these instructions are already mentioned in the link that I shared, the Google form, the Google Doc. So you guys can read it over there as well. And you need to share the link in the form as well. So I guess if any of our speakers, if any of our speakers want to say something, so you guys can, and then we'll just end it. Thank you. So I guess we don't have any further thing to say. So thank you so much, guys. Stay home, stay safe, and please obey whatever your local authorities are telling you to do. That's for your own safety. And we'll just come back with another event. Do give the feedback as well, because that's very important. And this was our first online event, so we need critical feedback so that we can improve it every time, every other time we do. So thank you so much, guys,
I
and we'll inshallah meet again. And thank you.